All right, this is still chapter 20 on what the book calls case studies and what I call when engineers don't consult a geologist. So here are some examples. The Leaning Tower of Pisa, soil compaction. Now, granted, I mean, this was done, I don't know, I mean, probably maybe before there were even geologists, so they didn't really know better back then. But the prime example of soil compaction and a bad foundation that this is not the only building that this has happened to. There have been recent ones, and the recent ones, it is like, well, maybe you should have checked out the soil and the underlying foundation and asked a geologist. Um, the Panama Canal. This was almost a huge failure, at least at the beginning. You should really go read these case studies in the book. They go into so much more detail. But the Panama Canal, when they were first trying to dig it out at sea level, because it's like now it like goes up and goes down, and so they have to like close this gate, and then like it floods up so the ships can go, and then they open that and they close the next gate. You find a video or something that shows that if you're interested in that engineering. But this is the geology of the Panama Canal. So you can see when everything is dipping towards where they were digging, you're going to have a lot of landslides. And they still have landslides now, but at first it was horrible and it pretty much killed the job because they just had to keep digging this out. And then not only that, but as they removed all this weight, then all of a sudden, now it's heavy on these two sides. So it started buckling. These two sides started coming down and the middle started kind of popping up and it buckled. And then this is a picture of the buckling here. It's totally destroyed the rail that they had brought in for the workers and the equipment and everything. So they actually gave up and then America took over and we did the floodgate thing. Or they don't call them floodgates, I forget, but where you like close the gate, like raise it instead. And then it mentions Boston's Big Dig. This actually was not a failure. This was much more recent, and I'm sure they did consult geologists on this, but it had a lot of difficulties getting that done. So Boston's Big Dig is, if you've ever been to Boston, there's a big tunnel that goes underneath the city and the harbor. The harbor being, up where it's underwater. So very interesting to read about that. But that was a success, but a lot of challenges. Dam failures and consequences. So we've talked about the downside environmentally of dams, how it can hurt the fish, and it changes like the sediment erosion rates downstream of the dam and things like this. But then if a dam breaks and you happen to have a city in that river valley beneath, then everybody dies. And here's an example of the St. Francis Dam that was constructed. So this type of dam, I forget what it's called. Again, I'm not an engineer, but it puts a lot of pressure on the sides of the canyon where it's constructed. Like an earthen dam where you pretty much just build up gravel and clay doesn't really put the pressure on, but this was putting pressure on the sides. They didn't consult a geologist. One side was full of a sedimentary rock that contains gypsum, which is easily dissolved. And in fact, they found out later in the lab that when you do what like a slake test and you put it in water, it pretty much just dissolved right away. So when they filled the reservoir up, so one side of the dam, pretty much the not the dam itself, but the supporting rock wall it's abutted against just kind of starts dissolving away. At the same time, the other side is schist, which is a metamorphic rock, and it's very foliated. It was actually foliated parallel to the river channel. So it's wanting to flake in this direction. So it just gives away in the same direction that the water is pushing against. So you can imagine how that was a fail. And here's an example afterwards where actually parts of the dam itself was constructed well. It was the sides of the canyon itself that gave way. A whole bunch of people died. I've been there and did a little geology study on that in college. Um, the book doesn't actually talk about how the foliation of the schist was parallel to the canyon, but that was one of the main reasons too. Um, Let's see, here's an example. Baldwin Hills Reservoir is on an active fault zone. Here's Three Gorges Dam in China that just has, oh my goodness, you should read this in the textbook. Just like just all sorts of awful effects of landslides, erosion. It's silting up in the dam, it's eroding more downstream, it's preventing the delta, so from getting the sediment. So now there's delta erosion, which they say could affect Shanghai. It has caused maybe um, the extinction of a river dolphin that used to be in this river. I mean, it's just like horrible, 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 horrible. If you read it in the book, all the things they talk about with with this dam, it's like reactivating faults because of the pressure and stuff. Like it's awful. They actually said in the book it was like a dam is built every no 6 dams a week. I think it said like it's kind of crazy. Like they're going really crazy with dams in China. Like, and I'm sure a lot of them aren't necessarily done to the same standards that we would do here in America. It's really frightening reading the stuff in the textbook about that. And then this is just dam benefits if done correctly. I mean, dams aren't all bad. People do them for a reason, and you have that cost benefit analysis. Like, yes, you're going to change the ecosystem here, but what are the benefits? And we do get power. You do get water supply, also some water control. If you were flooding downstream, it's going to help that. You get some recreation. There could be other species that seem to benefit from the change in the ecosystem, although you will have others. But then, downstream we have the bad. So we have the riverbank erosion, um, loss of livelihood from fisheries because the fish aren't going to be here as much. Loss of downstream aquifers. Oh, but good, you can have flood from irrigation again, kind of controlling that and taking it to the farming. We have displaced people and animals that, used to live up here that now has been flooded. And then the sedimentation where it silts up and fills up. Um, and this is greenhouse gas emissions from flooded vegetation. So as that dies of what's been flooded. So that's kind of, I guess, like not just dam benefits, but benefits and downsides, ecologically speaking, not, downsides of constructing it poorly. And that is it. Yes, that is it.